we have something else here. We have 1 minus cos squared x. Does that ring a bell as an identity? Go back to the very first section. What does 1 minus cos squared x actually equal? Anything? Do you see it? Okay. Doesn't 1 minus cos squared x actually equal sine x from that very first section? Right, nobody's seeing that? Let's see. Is this it right here? Okay. From the Pythagorean identity, okay, we know this is true always. So from here, if we actually move, because we know this is true, we can move things over to the other side, and this becomes sine squared x equals 1 minus cos squared x. Okay? So that is a result from this Pythagorean identity. So 1 minus cos squared x equals sine squared x. You might want to take just a minute to jot that down somewhere if you have that in your notes. When we get to this point right here, all right, then this 2 is simply a factor. Remember I drew the rectangles around the factors last time? These are all separate factors. Up at this one? Yeah, from here, you see that's where it was. But I took a 2 out of this expression and this term and this term. So the 2 is a common factor. I pulled it out. I'm left with 1. 2 divided by 2 is 1. And then this divided by 2 is cos squared x. If you were multiplying this in, then yeah, you would get back to this. But because 2 is a common factor in each of these terms, you can pull 2 out as a common factor. Okay? So now, 2's are gone. Okay? One of these signs are gone. So you can just do that in your work. This is sine x times sine x. So one of them are now gone with one of these. And we're left with what? Sine x divided by cos x. Sine x over cos x. And what does that equal? Yes, that equals tan. So that was a bit of a longer path, but it might have been a bit shorter path if you chose the other one. That's fine. Again, like I say, I didn't really think too much about it. I just wanted to show you that this would work either way. So tan x. And notice we didn't cross any barrier. We didn't add or subtract anything. But what I have on this side now, tan x, is the same as this other side. So we have proven that these two sides are actually equal. Okay? I'm just going to, we got just a few minutes left. I'm just going to go through, not going to do that example. I'm just going to show you this last page. I want you to write this down in the last few minutes that we have.